So we are now up to problem 5, and let's go through some of the next few problems. Problem 5 gives us this diagram. And what we see two intersecting lines. And we see that two of the adjacent angles are being given expressions in x. We're told to solve for x. Okay, so that's all we need to do for each one of these is solve for x. So clearly, this angle with 5x and this angle with 3x plus 20, they're adjacent angles. They're also a linear pair, because when you add these two angles together, you're getting a straight line. Well, we know that if angles are a linear pair, then they're also supplementary, which means that the sum of the two angles is equal to 180 degrees. So let's go ahead and let's use that fact to solve. So fx plus 3x plus 20 has got to equal to 180. We can remove parentheses. Then we can combine like terms. We've got a 5x and a 3x on the left, which can create an 8x plus 20 equals 180. Well, we've got to isolate our x variable, which means we've got to try to get rid of we've got our numbers on the right, we've got all of our x's on the left, we've got to get rid of this number. So we can do it, we can cancel that number out by subtracting from 20 on both sides of the equation. That will give us 8x equals 160. And if we solve for x, we divide both sides by 8, we then get x equals 20. So the answer to number 5 is x equals 20. Okay, good. Let's move on to number 6. In number 6, we're given a slightly different situation. Let's take a look at what we've got. Got ourselves again two intersecting lines, but we're not being given adjacent angles. What kind of angles are these? What are the angles that we've got in problem number 6? Well, think about it. Think about the different kinds of angles that we've learned about, and you'll realize that these are vertical angles. Okay, when two lines intersect, the angle which shares the common vertex but are on opposite sides of the vertices are vertical angles. So we've got that 3x minus 5 has got to equal x plus 30, because we know that when we deal with vertical angles, they have equal measure. Okay, so this is the equation that we're going to have to solve in order to solve for x here. Let's go ahead and do this. Let's try to get our x's on the left and our numbers on the right. So let's add 5 to both sides. We'll cancel out the number on the left, giving us 3x is equal to x plus 30 plus 5 is 35. And then we can subtract x on both sides to leave only the number 35 on the right, and that gives us 2x on the left. Okay, and then the final step we need to do is to isolate x, is to divide by the coefficient of x, which is 2, and that gives us x is equal to 35 divided by 2, which in slightly simpler form would be 17.5. This is our answer. Either is correct, but we usually prefer 17.5, or you could write this as 17.5. Okay, good. Let's move on to problem number 7. Again, a slightly different problem. Let's take a look at it. So this is another diagram, another illustration, and we've got a hint as to what the angles are. Well, more than a hint. It's clear that this line, if we call it line L, and whatever this line is, and this line segment is part of M, that they are perpendicular. They're intersecting at right angles, which means they're perpendicular. But as you recall from a review, that means that all of the angles that they form are perpendicular. So that this are right angles too. So that this is a right angle. And this is a right angle. And so is this entire angle a right angle. So what we see is that these are two adjacent angles that were given, the 2x minus 10 degrees and the 8x degrees, and that their sum is that of a right angle, and that means that they sum to 90 degrees, because a right angle is 90 degrees. Another way of expressing this is to say that the angle that's 2x minus 10 degrees and 8x degrees are complementary angles. So we've got the equation 2x minus 10 plus 8x equals 90. And we've got to solve for x. So it's the same kind of process as we've done before. Let's go ahead and take off the parentheses, because we have nothing in front of this parenthesis. Let us now group like terms together and do the summation. So 2x plus 8x is 10x minus 10 equals 90. Okay, and then we have to add 10 to both sides, and we get 10x equals 100. 10x equals 100. And we divide both sides by 10. We get x equals 10. So therefore, that is our answer, x equals 10. And one of the things you should always do when you get an answer, and if you have the time, is to plug the answer back in to the original problem and see if it makes sense. We haven't really been doing that a whole lot, but we should always do that. So let's go ahead and let's do it here. Let's plug x equals 10 back into this problem and see if it makes sense. Well, if x equals 10, then what is 2 times 10 minus 10, or 2x minus 10? Well, 2 times 10 is 20, minus 10 is 10. And what is 8 times 10, or 8x? That would be 80. So does it make sense? Are 10 and 80 complementary angles? Yes, they are, because 10 plus 80 equals 90. So the answer checks out. Let's go ahead and do the last problem for this video, which is going to be problem number 8. Okay, now problem number 8 looks to be sort of complicated. Actually, I'm going to do this on the next video. I'm trying to keep these videos as short as I can so that they can be played on YouTube. Okay, we're going to continue with problem 8 on the next video.